Chow, and I'm partnered with Han Wen, and we are solving the 2018 FRQ problem number 2. And in this question, it's proposed that researchers on a boat are investigating planktons in millions of cells per meters cubed, multiplied by the function p of h, which equals 0.2h squared e to the negative 0.0025h squared for all values between 0 and 30 of h, and is multiplied by f of h for all values past 30 of h. So we're asked to find p prime 25 and using correct units interpreting the meaning of p prime 25 in the context of the problem. So to begin, p prime 25 is just the derivative of p of h at 0.25. So what do? We see that there are two parts that both have the value variable h, right? And when deriving this, are we allowed to simply derive it straight through? No, that is a product rule. And so to set up, we find the product rule as d dx of f of x times g of x, which is the same as f prime times g of x plus f of x times g prime of x. This is interchangeable, but this is how I set it up. To begin, I want to split each into f of x and g of x. So p of h equals 0.2h squared times e to the negative 0.0025h. I make my f of x 0.2h squared and my g of x e to the negative 0.0025h squared. Now, to begin, p prime of h is your f prime of x and using the power rule, we know that it's 2 times 0.2, which is 0.4h times g of x, which is just this. Plus, we put this in parentheses because it's
should write measure there.
Here's f of x, which is just 0.2h squared multiplied by your g prime of x, which, if we use our e to the power of x derivative rules, it's just e to the power of x times times the derivative of that x, which is negative 0.005, because we're multiplying that 2 onto that coefficient behind that h up here. H times this entire value, e to the negative 0.0025h squared. Now we have our derivative of p of h, then we want to input the unit 25 into the prime. P prime 25, we're just going to replace every h value we see with 25, which is 0.4 times 25 times 25 multiplied by e to the negative 0.
Good jobs, people.
5.
Make sure that both people are doing both parts at some
5
point.
squared plus parentheses 0.2 times 0.5 squared multiplied by negative 5. I'm going to go down a little bit times.
Okay, we're still missing a win from. She's at home. Oh, I knew that.
25 times 25 squared And this should come out to
Because it's on iPhone SE.
negative 1.179. And because we know that it's in the density of plankton cells, we can interpret this value of P prime of 25 as the density of plankton cells in millions, changing by negative 1.179 million. At the depth of 25 meters.
Part B. Consider a vertical column of water in the sea with horizontal cross sections of constant area 3 square meters. To the nearest million, how many plankton cells are in this column of water between h equals 0 and h equals 30 meters? So we want to find how many plankton cells there are in total in this column of water, and we are told that P is the density equation, which means that we can integrate this to find how many cells there are in plankton cells there are in total, as the integral of density equals to total number of cells, plankton cells in this case. So we can find the total is equal to the integral from P of h, the integral of P of h, which is 0.2 h squared e to negative 0.0025 h squared dh. Now, for the limits of this, we are told that we are asked to find the plankton cells in this column from h equals 0 and h equals 30 meters, which means that there's 0 meters here and 30 meters here. Since we want to find the total number of plankton cells from here to here, that means our limits will be 0 to 30 as well, as we will be finding the number of plankton cells from up here all the way to down here. While that's the height, we also need to consider the area of each cross-section to find all the plankton cells, and we are given that an area of one small cross-section is 3 meters, which means we can multiply 3 to this integral. Then you can input this into the calculator and you get 1,675.415 million plankton cells. It says right here that the density of plankton cells is in millions of cells. Therefore, we can say that it's in this many millions of plankton cells. In context of this problem, we can say that there's 1,675.415 million plankton cells in a column of water from a height of 0 to 30 meters. Part C. There is a function u such that 0 is less than or equal to f of h, is which less than or equal to u of h, for all h greater than or equal to 30, and the integral from 30 to infinity u of h dh is equal to 105. The column of water in part B is k meters deep, where k is greater than 30. Write an expression involving one or more integrals that gives the number of plankton cells in millions in the entire column. Explain why the number of plankton cells in the column is less than or equal to 2,000 million. So, similar to part B, we want to find the total number of plankton cells in this entire column. The difference is, in part B, we only have to find it from 0 to 30, and now we have to find it of the entire column. So, it says that the entire column is k meters deep, but it also tells us we can still consider from 0 to 30 from our previous problem to find the total number of plankton cells, which means the column total will equal to the previous integral we found, as it's still the number of plankton cells from that entire chunk. So that'll be 3 times the integral of 0 to 30 p of h. However, we're missing this area right here. So now we need to add something to it. We don't know what k is, but we do know from this integral here that from 30 and to infinity of u of h is 105. And since that is the integral for all of the Plankton cells from 30 to infinity, we can assume, and the f of h could be considered the first column's total. We can, not the first column total, since u of h is from 30 to infinity, we can assume that k can only, at most, this infinity covers k, so therefore we can assume that from 30 to k, the area, it still has 3 because of each cross section, times this integral right here that's given to be 3 times 100, 3 times 105, as this covers from, as it says, for all each greater than or equal to 30, and this is greater than or equal to 30. That's why we can utilize this. And that would bring out, and then if you input that into the calculator, that would give you 1,990.415 million Plankton cells. So this is f of h, and since f of h is greater than or equal to 0 and u of h is greater than or equal to f of h, we can add u of h and f of h to get the total number of Plankton cells. Now, we know that there are this many Plankton cells from a height of 0 to k meters. So, since this is the entire column, and this is the maximum, and this is the amount of Plankton cells throughout the entire column, we can then assume, in this part of our question of why the number of Plankton cells is less than or equal to 2,000 million, and 1,990.451 is less than or equal to 2,000. Therefore, since it's bounded by this number, therefore we can assume that the number of Plankton cells from here to here is definitely less than 2,000 million.
We are given the fact that a boat is moving now on the surface of the sea, and at time greater than 0, the position of the boat is given at point x of t, comma y of t, where x prime of t is 662 sine 5t, and y prime of t is 880 cosine 6t. Now, we're also given the fact that time of t is measured in hours, and x of t and y of t are measured in meters. We're asked to find the total distance traveled by the boat over the time interval from 0 to 1 second. So,
It's still alive, buddy.
now we know that In terms of position, the derivative is simply velocity. So, we know that x prime t is just the velocity in its x direction, and y prime t is its velocity in the y direction. As for the total distance traveled in the time interval from 0 to 1 second. So, to set this up,
And then I come in here with the part that came in of this part. So that's the part that you restart anyway.
total distance
No.
is usually
Yeah, the other part
definite integral
That part.
from
And then,
bounds A to B of the velocity
Actually, no, we're good.
in terms of time. Now,
Function is one.
we're given two values for velocity. What do?
And
We have to
right here. And two,
have the magnitudes of both vectors,
and
which
given
is
the context of the situation,
magnitude is the square root of your x prime t squared
now write it out.
plus your y prime t squared.
Oh, you did like 1,000 videos.
And given our data, now we can plug it in from 0 to 1. So our distance traveled, or x total, equals
Okay, ready?
the integral from 0 to 1 of the square root of x prime of t
Third and second.
squared plus your y prime of t squared. So plugging in our values, which is 662 sine 5 of t and 880 cosine of 6t dt. Plugging in the calculator, we get the value of 757.455.862. What this value means is that the boat traveled 7,507.455.862.
Say this for
And 0 to 1 second.
Yeah, I'll take